Okay. Good afternoon, everyone. My name is Irina Gokhaeva, and today I will be presenting you the key findings of my 2-month internship in I3S lab, particularly in the Wimmics team. And I was fortunate to be guided by my supervisors, Elena Cabrio and Anaïs Olanier. For my presentation, I will be following a plan. I will start with an overview of the Antidote project. I will then present to you the main objectives of my internship, the hypothesis for our research. I'll discuss the methodology that we use to conduct our research and collect data. I'll present the key results, and finally, I will summarize the conclusion that we drew from our research and its application for the future. The objective of Antidote is to improve the explainability of AI systems in the medical domain. So the objective of this project is to support medical professionals in their decision-making process. The key feature of this project is that it combines argumentation theory with explainable AI. The main goal is to develop high-quality explanations for AI predictions. And to do that, to achieve that, annotated data sets must be created. These data sets should include correct answers to medical questions, as well as explanations, detailed explanations of why certain options are incorrect. So, isn't it true that annotation sets the base for any AI model? Since the project uses annotated data sets to train AI system, it is essential, important to accurately annotate medical texts. During my internship, I not only annotated clinical texts, but I also studied disagreements among annotators to then develop a taxonomy of disagreements that improves how we tag the clinical case texts. So my contribution was to find sources of annotators, disagreements, and also try to refine annotation guidelines. The primary objective of my internship was to improve the quality of annotated medical data, and to do that, I focused on more specific goals, which were to annotate 100 clinical cases following the guidelines. I also aimed to create a taxonomy that categorizes disagreements among annotators. This taxonomy helps identifying the types and sources of discrepancies in annotation, and it helps understand why and where these disagreements occur. And finally, I worked on suggesting some improvements to the annotation guidelines. My personal goal was to deepen knowledge and my skills in linguistics and natural language process. The main question of this research is what factors impact the quality of medical data annotation. To address this question, we put two hypotheses. The first one posits that the complexity and the presentation of clinical cases lead to higher disagreement rates. This includes factors such as the use of technical terminology or the complex nature of medical texts. The second hypothesis suggests that the specific characteristics of argumentative elements, such as the subtlety of claims and strength of evidence, are associated with higher disagreement rates. For this research, we utilized the Antidote dataset, which comprises clinical cases sourced from the Casimedicos project. And to facilitate the annotation work, we used the PRED, which is an interactive web-based tool for text annotation. The annotation process involved a team of 3 linguists, including myself. Each of us followed the guidelines, and each of us annotated at least 100 clinical cases. We identified and marked argument components, relations, diagnostics, treatment, and linguistic markers. So after completing the annotations, we calculated the inter-annotator agreement to assess the consistency of our annotations. We used the F1 score. This is a metric that balances precision and recall to quantify the agreement, and based on this F1 score, we created heat maps. So now let us have a look at the screenshot presented here. I will turn on the pinpoint, the laser. So we have marked the argument components, which are premises and claims, as well as argument relations, which are attack and support. So a claim or a premise may attack or support a claim or a premise. We also attacked diseases, diagnostics, treatment, and linguistic markers, such as here it's the opposing conjunction but. Here we can see the heat maps, instance-based agreement heat map and token-based agreement heat map. The difference between them is that the token-based heat map analyzes agreements on individual words or token, while the instance-based deals with agreements on entire sentences or for a broader view. So it is clear that when working with larger blocks of texts, the level of disagreement increases. Given the observed differences in annotations, it is essential to understand the reasons of disagreements among annotators. Now let us have a look at the comparison tool. On the main, the comparison tool was the KDiff3. On the main window, we can see the annotations of the three linguists. The bio method was used here. Bio is short from beginning, outside, inside, outside. So we annotated chunks. If a word or a token belongs to a chunk, it's got a prefix I inside. If it begins the chunk, it's got the prefix B for beginning. And if a token does not belong to a chunk, it's got the prefix O for outside. And if the bio items do not match, the program highlights the discrepancies in different colors. With the help of this program, I have created a table of disagreements met during the annotations. Now, I analyzed the disagreements, and throughout the analysis, I was able to create a taxonomy that categorizes the disagreements into 4 main types. For me, it was the most interesting part. The first category would be guidelines ambiguity. It refers to situations where the guidelines are unclear or insufficient, and when guidelines lack precision, and the annotators may not exactly know how to handle certain cases. The second category is the human factor. It deals with differences in annotators' knowledge or experience in various levels of expertise. Next category is the text complexity. It involves the inherent difficulty or ambiguity of the text being annotated, and complex medical cases can be challenging to interpret and to annotate consistently. The last category is the sloppy annotation. It includes careless mistakes or inconsistencies made during the annotation, and these errors can occur due to the lack of attention or due to fatigue or simple oversight. Now, let's look at the disagreement table that I have created. So here we can see the number of the case in which the disagreement took place, the text of the disagreement itself, so the chunk or a phrase that we annotated, the argument component that each annotator gave to this chunk. We can also see if there are differences, disagreements by pairs of annotators, the disagreement itself, and the category of disagreements from the taxonomy of disagreements that we have created earlier. Our findings validated. In our analysis, we identified a total of 355 disagreements, and guidelines ambiguity accounted for the first place, followed by sloppy annotation, then by text complexity, and by human factor. And the findings highlight that the majority of disagreements stemmed for guidelines ambiguity, and this underlines the importance of having detailed and clear annotation guidelines. And by addressing these ambiguities, we can significantly improve the quality of our annotations. So our findings validated the hypothesis that the complexity and presentation of clinical cases lead to higher disagreement rates. However, the specific characteristics of argumentative elements had less impact on disagreements that we have expected initially. Now I would like to suggest some strategies to minimize disagreements. First of all is to add some refinements to the guiding lines, like for example to define punctuation inclusion, because it was often the case where we were not sure if we should or not include full stops or question marks or exclamation marks. So yeah, to add this point will reduce the amount of disagreements. Then the medical texts are very complex, they're various, and we need some more examples for each argument component. It is also important not to overload the guiding lines, but it's important to give some more examples for each argument. And very important, conducting adjudication sessions, because I had these sessions with one of the annotators, but not with the other one. With the first one, our disagreement rates were much lower. So now I would like to pinpoint the main key findings. So we identified the sources of annotation disagreements. We developed a taxonomy for categorizing them. And we also suggested the guideline improvements to reduce these disagreements. In the future, it would be interesting to analyze disagreements in argument relations, such as support and attack. And also would be interesting to study how complexity of clinical texts affect annotator agreement. I think that in the future, AI will likely become one of our most valuable colleagues. However, no matter how advanced it becomes, it won't be able to join us for lunch, will it? Now I hope you have a bigger picture on this topic. And I would like to thank Indra Institution and Wimmics team for giving me the opportunity to work with you, and particularly my supervisors, Elena Cabrio and Anna Isolenie, for being there for me throughout the whole research. Ekaterina Sviridova, thank you so much for the precious pieces of advice. And thanks to Christian Cardellino for the technical part. Thank you so much. Now, I hope you found this study as interesting as I do, and I welcome any questions or comments that you might have about this research. Thank you for your attention.
Thank you. Find where to stop.